My students, welcome back to class. We are rounding off on heat. We are now on latent heat. So we are rounding off on our last classes on heat. So I will advise you to pay special attention to these last classes of heat, because on these last classes of heat, I want to give us strong foundation that will help us to solve all types of problems on heat. Yes, that will help us solve any type of question we encounter on heat, be it on specific heat capacity or latent heat. Okay, on today's lesson, on today's tutorial, you will learn, I will teach us how to solve problems that involve specific heat capacity and also involves latent heat. How to solve the joint problem. Let's take the question that will take us there. And the question says, I read, how much heat is required? How much heat is required to change 2 kilograms of ice to water at the same temperature? They give us specific latent heat of fusion of ice equals to 33600 joule kilogram per 1. I always like to remind my students whenever I come to solve this type of problem that whenever the questionnaire use the same temperature, know for sure that the problem borders on latent heat. Yes, so this problem on the board is on latent heat and it's a simple one. The question asks us how much heat is required to change 2 kilograms of ice to water at the same temperature. That is how much heat that is required to melt ice to water at the same temperature without temperature change. And I said it again, once we hear at the same temperature, which means without temperature change, know that we are talking of latent heat. No wonder they gave us specific latent heat of fusion of ice. They give us specific latent heat of fusion of ice. So we simply say quantity of heat. I write it, quantity of heat that is required to change this 2 kilograms of ice to water, denoted by H, is equals to the mass of this water, mass, denoted by M, times the specific latent heat of fusion of ice, specific latent heat of fusion, which is denoted by, let me put it L. Okay, so we have that quantity of heat that will melt this 2 kilograms, this mass of ice to water, is equals to the mass of this ice times the specific latent heat of fusion of ice. If I represent this now written in word in symbols, it will be H, which stands for quantity of heat. Put this equals to M, which stands for mass, times L, which stands for specific latent heat of fusion. If I continue, I will substitute the value, the data, that is the information given to us in this question, into this formula. And I'll start with the first one, which is H, which is the quantity of heat. Did they give us any quantity of heat? No, they say we should find. The question says how much heat is required. That is stand for quantity of heat. So I'll still write it H. That's what you are solving for. You don't know the value. Put this equals to. Now, mass, did they give us any mass? Yes, they give us 2 kilograms. So I substitute 2 here. Put this times. Specific latent heat fusion of ice, they give us, yes, they give us 33600. So I write 33600 here. I say it's a simple question. Finally, we have our quantity of heat to be equals to what? Multiply this and this. And if I multiply, it will give me, I will say 2 times 33600 will give me what? It will give me a quantity of heat to be equals to 67200. Yes, 67200 joule, because we're talking of heat. Heat is measured in joule. And if I want to put it in standard form, I'll put it like this. Finally, our quantity of heat will be equals to 6.7 times 10 raised to power what? I want to put it in standard form now. Watch out. I'll start from this end and I'll count. 1, 2, 3, 4. I go 4 places. Put this point. This is where the point is. So it will be times 10 raised to power 4. Answer.